All right, let's take a look at this question. This is one of our enthalpy of dissolution questions, right? So we have the delta H of dissolution. And essentially what we're doing is putting a salt, calcium chloride in this case, into water. Notice we've changed from a solid to aqueous. So we essentially, just like you would take a teaspoon of sodium chloride salt, the salt we eat, and dump it into water. We've done the same thing with calcium chloride. It actually has a pretty high, one of the highest salts, enthalpy of dissolution. So, and it's exothermic here, you can see. So it should heat the water up. So that's our first clue, is that our final temp, so we're solving for a final temp, should be higher than our initial temp, which is 25 degrees. So it should be something higher than 25 degrees. So with one of the big things with enthalpy of dissolution is we have to add the masses, right? We have a mass of water here, which might be different for you, and a mass of the salt. Yours should be the same. So 155 plus 15, we have 170 grams. That's our mass, our total mass. So we're going to use this, Q equals mass times specific heat times change in temp. Specific heat, we're going to use waters because it's mostly water. Don't forget your units, it's joules. We're solving for delta T. So that means we're given mass, which is 170. We need to figure out Q. Remember, Q of the system is the negative Q of the surroundings. And so we need to figure this out. Now, Q needs to be in joules, but we're given the value in enthalpy, which is kilojoules per mole. So the first thing I'm going to do is solve for how many kilojoules. And so again, I need this mass separately here. I need to figure out how many moles, right? So Q is also equal to delta H times N, because this is kilojoules per mole and we're multiplying it by moles. That'll tell us how many kilojoules exactly for this specific problem. So I'm going to take my 15 grams of calcium chloride and get into moles. Grams per mole. Molar mass happens to be 110.98 per 1 mole. So I divide that value out and I get 0.135 moles. And then I'm going to take that number and multiply it by right. So this is saying for every 1 mole, since this is a 1 in front, we have to account for that. There's no, if it was 2, we'd have to divide this by 2. But for every 1 mole of calcium chloride, there's negative 81.5 kilojoules, or the negative is just saying that it's released, right? It's exothermic. And so for this specific case, I have 0.135 moles. So that means when I multiply these together, I get my number of kilojoules. Now I times that by 1,000, get joules. Now, because of this, right, heat that's going into the water is the opposite of heat from the system. So I'm going to use this as a positive value, right? Your change in temp, and to think about that, your change in temp should be positive. It should go up. And so the heat being released is going into the surroundings. And so this heat being released is positive for the surroundings. So we now have 11,015 joules is equal to 170 total grams times 4.184 joules per gram degrees C times delta T. So if I solve for delta T, so 11,000, I'm going to divide by 170 times 4.184. And we see my joules cancel, my grams cancel. I'm left with degrees C. And I get 15.5 degrees C. So delta T is equal to T final minus T initial. This is 15.5. And this is 25. So T final is equal to 15.5 plus 25 degrees, and I get 40.5. So if I type that in, correct. Okay, so a lot going on here, right? We gotta first figure out that this is how many moles of this is, so we can use that with the kilojoules per mole. Then we have to take the total mass when we're using our Q equals M. So the total mass here, and then we have to use the amount to solve for the amount of heat. Remember, how much heat can be transferred depends on the amount of stuff. And so enthalpy is telling us how many kilojoules per mole, but the Q here is actually how much heat is transferred for this specific case, which depends on the amount of moles. Okay, hopefully that helps.